Hello, folks. Welcome to factoring day 3. In your notes, it will say day 3. Let's warm up. Let's recall expansion. Expansion using distributive property. What is 3 times x? 3x. What is 3 times 2? Positive 6. Expanded. Good. Likewise, when we factor, we look for something common between both terms. In other words, can each term be divided by that same sum? That will everything looking good and not with decimals. So you can see that common between 3x and 6, there's no x common, but there is a 3. And we'll take that out and ask ourselves, how does 3 become 3x? Well, it's multiplied to x. How does 3 become 6? It's multiplied to 2. So this is just the backwards way round of expansion, is factoring. Okay, 3 is called the common factor. So when we look at an example like this and we factor this, we look for something common between 2x and 4. So inspect the integers first. Is there something common between 2 and 4? Yes, there is a common factor of 2, because 2 can be divided by 2, and so can 4 be divided by 2 without leaving decimals. Anything else common? No. So then we ask ourselves, how does 2 become 2x? Well, it will be 2 times x. How does 2 become 4? It will be 2 times 2. Remember, we're always looking for multiples, like as if we were doing distributive property. Factoring this one, what is common between 5x and negative 15? Well, the signs don't really matter at this point. Just inspect the integers. 5 and 15 have a common factor of 5. 5 times what will give me 5x? Just x. 5 times what will give me negative 15? Now the sign is important. It would have to be negative 3. Remembering we are multiplying across these arches. So we can check our work and go backwards and know that we've done this right. Now, what about factoring this one? Recall now this was going back to our introduction to factoring quadratics. We look for two numbers that multiply to 15, and it's positive 15, and yet add to 8. If I'm looking for a multiple of two numbers to give me a positive value, those numbers must both be positive or both negative. But then when I consider that my sum has to be positive, therefore I know my numbers have to be positive. Thinking of the rainbow factor of 15, we can have 1 and 15 or 3 and 5. Take a look at these pairs. Which ones add up to 8? And it would be this one here. So I take those two digits, I set up my binomial brackets. I start with an x in each of them, because when I multiply those together, I get my x squared. Then I simply place these numbers in any order. It can be plus 3 plus 5 or plus 5 plus 3. And knowing that those two multiply together will give me my last number. And when I add them together, we have 3x plus 5x will give me 8x in the middle. So all the relations in 1 through 3 are linear. They all have degree 1. Degree 1 being that the highest exponent ever is 1. These are hidden exponents here, right? Highest exponent is 1. And they all have a common factor. Quadratic relations of degree 2 might also have a common factor 2, although our example in question 4 did not. So let's first of all look at common factoring each standard form quadratic here. So now we need to not just concern ourselves with 2 terms, but 3 terms. Is there something common between 2x squared, 4x, and 8? So focus on the integers first. So we're looking at the integers of 2, 4, and 8. What is the common factor between those 3 terms? In other words, a number that will go into all 3 of them. And you would be right if you said 2. So let's take that 2 out and then say to ourselves, okay, what do I need to multiply 2 by to get each of these terms? The first one would have to be x squared to get 2x squared. The second one would have to be 2x, because 2 times 2x gives me 4x. And the third one would have to be a 4, right? Now remember, we could go about this a different way as well. I did show you yesterday, and maybe I'll show you that on this part B. So what would be common between 3x squared, negative 6x, and negative 15, if there is one? And there is, and it's 3. It's always going to be a low number. So let's take that 3 out. Now remember, to get the terms that are inside this bracket, we just divide each term by 3. So 3x squared divided by 3 just gives me x squared. 6 divided by 3 gives me 2, and it's negative 2. Negative 15 divided by 3 is negative 5. So you could do it that way if you like, and just get your calculator out and put negative 6 divided by 3 to give you this value. Okay, so if your head's aching, please do it that way. This one has a common factor of 6, I think. 6 goes into 6, it goes into 24, and goes into negative 36. So let's take a 6 out, and then we'll have x squared. 24 divided by 6 is 4. And negative 36 divided by 6 is negative 6, and we're done. And the last one, why don't you press pause now and check your answer with me in a second. And there you have it. Some quadratic relations have a common factor, and then we can factor them into two binomials like we did a couple of days ago. So now it's important that you're reading the question properly and completely. Factor each standard form completely, i.e. common factor, then binomial factor. So let's start out how we started just above, looking for something common between these three terms, which would be a number 2. And let's extract this out of there. Now this in itself now. So now we can set the 2, set it and forget it. And then let's factor this trinomial. It's called trinomial because there's 1, 2, 3 terms. So we're looking for two numbers that multiply to 2 and yet add to 3. And that's super easy. It's just 1 and 2. So we'll have x in the beginning of each of the brackets, and then plus 1 and plus 2. The next one, common factor of 3. We'll extract that out, and you should get this. Remember, you can press pause and replay. Now let's factor this. Binomial factoring this. We're looking for two numbers that multiply to 3 and you add to negative 4. Oh, here's a tricky one maybe. Multiply to positive 3 and yet add to negative 4. Remember, with multiplication of two numbers, when we multiply two positives together, we always get positive. Two negatives together, we get a positive, but then they'll add to a negative. So we're looking at negative 1 and negative 3. Negative times a negative gives me the positive, yes. And negative 1 minus 3 gives me negative 4, which is what I was looking for. So those are the two numbers that I will place in my binomial brackets. It doesn't matter which way around. And we are done. Now it's on to practice questions for you. So hopefully that's a nice, short, sweet lesson. Please replay it as many times as you need to understand it thoroughly. Take care. Bye-bye.